Thank you, Geert. In fact, yes, we do have received a couple of questions. The first one was actually put forward at the end of the first presentation, but I believe that your presentation more or less deals with the issues. If you have anything to add, please do so. So the question says, thanks for the presentation. I would like to have an idea if the amount of heating period is related with the inertia, heat capacity of the walls, and to know something more about the simplified method and expected precision.
Sorry, can you repeat the question?
Yes, of course. The question goes, we would like to know something more if the amount of the heating period is related with the inertia, the heat capacity of the walls, is the first part of the question.
So it is not related to the duration of the experiment. Of course, when we have more thermal mass in the building, we will have more influence of this thermal mass. So, for example, if you have a sunny day, the heat that is being charged by the thermal mass during that day, it will be discharged into the next. That's also the reason why we propose to take into account the thermal lag by relating the heating power to a weighted average of the current solar radiation and the solar radiation of the previous day, to somehow take this into account.
Okay, and the second part of the same question is to have some more details on the simplified method and the expected precision.
That is a rather general question, I think. So what we try to do is to visualize the reliability of the coheating test by considering simulated experiments with different durations and different start dates. So we clearly see the assessment results converging towards, given the correct assumption, converging towards the target value, and so given a sufficient duration and given the correct model to fit to the data, we are able to obtain reliable results. Of course, it depends. We fixed the test case and we fixed the analysis methods we considered. So it might as well be in the case of a very well insulated dwelling which has an important capacity. It might as well be that the reliability will only be sufficient after some time, or after a considerable amount of time.
Very good. David, Dominique, for all the questions, in case you have anything to add, please feel free to. The second question received is, do you estimate the physical error of the measurement equipment?
You mean measurement error on the sensors? We do consider it not directly, but it is considered as an error of in the heat balance which we showed. So we have all of the heat inputs and heat gains and heat losses towards the indoor temperature, and we have a constant there which actually makes explicit the error that is made due to measurement errors, but also due to modeling errors.
Okay. The third question is, have you done some checking on the behavior of the flow meters?
So in the last test case, we've used the heat flux sensors to better estimate the actual obtained performance improvements. Of course, there we also have work on the basis of aggregated data. So and there are quite some assumptions involved there to have an estimate of the thermal resistance of these components. And in addition to that, so there is some uncertainty on the model which we are fitting to it, and there's also an uncertainty on. We also know that the components are not. It's not a one-dimensional heat flow. So we have measurements at some points, but we are not concluding. We are not using that to conclude anything for the component itself. We've used it to look at to compare the performance improvements which you saw on the basis of the analysis result with the actual performance improvements of the component itself. For the measurements of the components, we saw that we had quite a close. We've calculated the improvement of the thermal resistance on the basis of the thickness of insulation which we added, and we saw that there was a great resemblance with the actual measurements. So the performance improvement or the thermal resistance improvement on the basis of the measurements. If that answers your question.
Okay, we have a couple more questions, but I think it's better that we continue with the presentations and we can answer some of the rest of the questions at the end during the discussions.